Hello, we're on 4.01 Algebra 2 notes today. And so we're starting a new unit, and this unit is on exponentials. So we're going to start by talking about exponents. So there's a couple rules that I want to review with you guys first. So first rule is about negative exponents. You're never allowed to leave a negative exponent in your problem. So you would take a raised to the negative n power, and whenever you see a negative exponent, it means you're going to take the reciprocal. So I know sometimes in middle school they talk about putting it over 1, and think about making this negative exponent into a plus with an arrow through it. It's going to go to the opposite place. So if it's negative and it's in the denominator, it'll go up to the numerator. Just take the reciprocal. If it's negative in the numerator, like it is here, it'll go to the denominator and become positive. There's nothing left in the numerator, so it must be a 1. So if you had x to the negative 6th power, you could rewrite that as, so make a bar, and then anything that's negative goes to the opposite place. So it's negative x, it has a negative exponent, so it's going to go down. And then there's nothing left here, so that becomes a 1. Now, it doesn't matter if the actual number or variable is negative, just if the exponent is negative. And let's try negative 2x to the negative 2nd, y to the 3rd. So to rewrite that, start with my bar. This is like all over 1. So negative 2 has a positive 1 exponent, so that's going to stay on the top. If it's positive exponent, it stays. Negative, it goes. X to the negative 2nd has a negative exponent, so that's going to go and become positive. Y to the 3rd is positive, so that would stay in the numerator. Okay, so just a few examples if you have a negative exponent. So your negative exponent, you're taking the reciprocal. Okay, so what if we have a fraction? So if we have a fraction, then call this number 1, x to the 2nd over y, let's say raised to the negative 3rd. So there's a couple different ways you can think about doing this. So the first way is when you have a negative exponent, so this one's on the whole set of parentheses, again, you take the reciprocal. So this would become y over x squared raised to the positive 3. So once you flip it, so I just flipped these two, then it becomes positive. And then you can simplify by kind of just distributing it in. So y to the 1st raised to the 3rd, when you raise a power to a power, you powerply, which means you multiply. So that would be 1 times 3 is 3, over x to the 2nd raised to the 3rd, so 2 times 3 would be x to the 6th. Okay, so again, negative exponents take the reciprocal of that. Another way you could do that one, just so you have a couple options here, is you could powerply right at the beginning and say 2 times negative 3, right here, is negative 6 over y to the negative 3rd. And then, again, we can't leave negative exponents, so we need to get rid of them. So the first one is x to the negative 6. It has a negative exponent, so it's going to go to the bottom and become positive. Then y to the negative 3rd is a negative exponent, but it's already in the bottom, so that one's going to go up to the top. And notice you get the same answer either way. So just 2 different options that you could do. And another rule that I'd like to go over is anything raised to the 0 power is 1. So if I had x to the 0, that gives me 1. If I had 4x over 2y raised to the 0, that gives me 1. The whole thing is being raised to the 0 power. If I have 3x to the 0, y to the 9th, then 3, there's no exponent on it, which means it's to the 1st power. X to the 0 becomes a 1, and y to the 9th. So that would become 3 y to the 9th. All right. Now, let's combine some of that. Also, when you are multiplying coefficients, let's write that in too, actually. So when you multiply, you're going to multiply your coefficients and add your exponents. So that's for multiplication. For division, you would subtract your exponents and divide your coefficients. And that's going to apply if you just have any type of multiplication, even if you're foiling. That's what you're always going. If you multiply, you're going to add. If you're dividing, then you divide your coefficients and subtract your exponents. If you're raising a power to another power, I like to say we powerply, which sounds a lot like multiply. Again, we'll just write this in. Never leave negative exponents in your answer. And something that's important to remember that a lot of students forget is always remember to raise your coefficient. So that constant, the number in the front. So a constant, remember, is just a number. To the exponent as well, if it's inside the parentheses. And a lot of students forget to do that. Okay, so just some important rules to remember. Okay, we left off on 4. So let's go to number 5. Try this one. So negative 6 x to the second y to the 6th raised to the 3rd. Pause the video and see if you can do this one on your own. All right, so hopefully you said negative 6. So sometimes the negative throws people off. But again, this has no exponent, so there's a 1 there. So you want to have negative 6. 1 times 3 is 3. Then x, 2 to the 3rd, power to a power, powerply, which means you multiply. And 6 to the 3rd, power to a power, you powerply there. You always want to simplify. So you can type this part into your calculator, negative 6 raised to the 3rd. Make sure you remember that negative in parentheses. It should give you negative 216. And we keep x to the 16th, y to the 18th. Those are positive exponents. So we're good on that one. Let's try another one. So this time let's do 4x to the negative 5th, y to the 6th, times negative 12x y to the 8th. And the thing with these, a lot of times there's more than one way to doing it at different orders, and that's okay. So, you know, some of you like to be very consistent, and that's great. Others just kind of look at it and start going, and that's okay too. So 4 times negative 12, we're just multiplying these. So we get negative 48. And then I've got x to the negative 5th times x. There's no exponent. It's not to the 8th because that's not in parentheses. So that would just be a 1 there. And when I'm multiplying, I multiply the coefficients, add your exponents. So here we'd have negative 5 plus 1. So negative 5 plus 1 would give me negative 4. And then y to the 6th and y to the 8th. Again, multiplying, add the exponent. Think of it as you're always going down one operation. So if you're raising something to a power, you go down 1 and you multiply the exponents. If you're multiplying the two terms together, then you're going to add the exponents. And if you're adding, you're just going to keep the exponent and add the coefficient. So think of it always as you're going down one operation. All right, so we got negative 48, x to the negative 14th, x to the negative 4, y to the 14th. And now I can't leave my answer like that because I have a negative exponent and I'm not allowed to leave negative exponents. I'm going to make a bar. Negative 48, what exponent is on that? Well, there's nothing written directly on it, so it must be a 1. Now, don't get confused here because it doesn't have a negative exponent. It's just a negative number in the front, and that's okay. That can stay anywhere. So the negative 48 will stay in the numerator because it has a positive exponent. X to the negative 4 has a negative exponent, so that's going to go down because right now it's in the numerator. And once it switches places, it becomes positive. And I just go in order, 1, 2, 3. And then y to the 14th has a positive exponent, so that's going to stay. So that would be my final answer. I'm allowed to have negatives. I'm just not allowed to have negative exponents left in my answer. Let's try another one. So 42x over 3x to the negative 4th, y to the negative 2nd, over negative 2. If you think you're ready to try this on your own, please pause the video and give it a try. All right, we've got a couple negatives here though. So again, there's a couple different ways that you could try this one. I'm going to first flip it to get rid of this negative exponent out here. So I'm just going to take this numerator and bring it up to take the denominator and bring it up to the numerator, and then flip that 42x. Notice the negatives that were in the bottom are still negative. All I'm doing is taking the reciprocal so that this exponent becomes positive. And then I'll worry about working my way inside. So you could square everything at this point if you want, or you could get rid of your negative exponents, or you could reduce. So again, there's a lot of different ways you could do this. I am going to first start by getting rid of my negative exponents. I always like to do that first. So I got rid of the negative over here. Now I need to get rid of the negatives inside the parentheses. So to do that, I'm going to go through each one and ask stay or go. So 3 is to the first power, so it's positive exponent, so it stays. I go in order, left to right, top to bottom. X to the negative 4th has a negative exponent, so that's going to go. So it goes to the bottom, becomes positive. Y to the negative 2nd is a negative exponent, so that's going to go to the bottom, become positive. Now I go to the bottom, 42. That has a positive 1 exponent, so that's going to stay in the bottom. X has a positive 1 exponent, so that's also going to stay in the denominator. And that's all being raised to the second power. All right, again, you still have some options. You could reduce here if you wanted, or you could square it. That is up to you. I'm going to reduce here because I want to combine my x's before I power apply everything. So I'm going to reduce the 3 and 42 while I'm reducing. So 3 goes into 42 14 times. So now I just have a 1 on the top, 14 on the bottom. Now I have x to the 4th and x to the 1st. So I'm going to keep my base, add the exponent. So when I'm multiplying, I go one operation down. So if I'm multiplying, I add the exponents. Keep my y to the 2nd, and that's all being squared. And now I'm going to square everything. So I have 1 squared over 14 squared. Here's where you need to make sure you remember to do that. 14 squared also. Power to a power, 5 to the 2nd power, power apply, that gives me to the 10th. Power to a power, 2 times 2 is 4. And then my final answer, 1 squared is 1, 14 squared is 196, x to the 10th, y to the 4th. And I did it in a lot of steps, but again, there's many different ways you could go about it. That's just one way you could do it. Okay, let's try another one. 63, x to the 11th, y to the negative 5th, 9x to the 15th, y to the 8th. Please pause the video here, and I want you to simplify and reduce this. So get rid of your negative exponents, combine anything that's possible to combine, and reduce. All right, so here, first thing I like to do is get rid of my negative exponents. So I always start with that every time. So 63 to the first power stays. X to the 11th, positive exponent, stays. Y to the negative 5th has a negative exponent, so that's going to go to the bottom and become positive. So going left to right, now I'm on the 9. 9 has a positive 1, so it's going to stay. X to the 15th, positive exponent, so it stays in the bottom. Y to the 8th, also positive. So that's going to stay. Okay, I also can reduce here. So I have the 63 and the 9, the coefficients. So 9 goes into 63 7 times. And that gives me 7x to the 11th over, and here I have y to the 5th and y to the 8th. So that will give me, I'll have x to the 15th and then y to the 13th. And I've got one more thing I can do on this one. Notice I have an x term in the top and the bottom. So I'd ask myself, where do I have more x's? I have more in the bottom. How many more? Well, I have 15 there and 11 here, so I have 4 more. So I keep it in the bottom as x to the 4th, since there's 4 more in the bottom. I can reduce that. You can also think of it as subtraction. If you did always subtraction, if you're doing 11 minus 15, you would end up with x to the negative 4 on top and then have to get rid of the negative exponent. I like to, when I'm doing division, just ask where do I have more and how many more, and that's where it will go. So if I'm more in the numerator, it stays in the numerator. More in the denominator, it stays in the denominator. Next, we've got x to the 7th, y to the negative 2nd, z to the 0, over x to the negative 2nd, y to the negative 4th, z to the 3rd. Please pause the video and simplify this. All right, so first thing, go through, get rid of your negative exponents. Go through each one, left to right, top to bottom. X to the 7th is a positive exponent, it stays. Y to the negative 2nd, negative, it goes and becomes positive. Z to the 0 is just 1. So I don't need to write that. If you want to write that here, you can. X to the negative 2nd is in the denominator and it's negative. So to get it to become positive, I need to bring it up. So it goes and becomes positive. Y to the negative 4th is negative in the denominator. Bring it up, becomes positive, and z to the 3rd would stay. Now time to simplify. I have x to the 7th times x to the 2nd. Keep the base, add my exponents. And the bottom, there's nothing to combine down there. Now I look and I say, okay, do I have anything I can reduce here? And I see I have, and the only reason we can reduce these is because it's all multiplication. If there was any addition in between here, we wouldn't be able to reduce like this. So where do I have more y's? I have more y's in the top. How many more? 2, so it becomes y to the 2nd. So hopefully you got that same answer on your own. Okay, and then let's do 12xy over 3x squared times 9x to the negative 3rd over y to the 5th. Okay, pause the video and try this one on your own. All right, again, multiple things you can do here. If you're having trouble getting started, try just multiplying, getting them into one fraction. So multiply straight across the top and straight across the bottom. So 12 times 9 would give us 108. X to the 1st times x to the negative 3rd. Keep the base, add the exponents. So 1 minus 3 is negative 2. Y to the 1st. And in the bottom, everything's different. So it just becomes 3x squared, y to the 5th. And now, if you weren't able to start, go from here, now reduce that on your own. So pause the video and go ahead and finish that up. Okay, so again, you should have reduced your 108 and your 3 and get rid of your negative exponents. And your final answer should be 36 over x to the 4th, y to the 4th. On your papers, I should see the work as to how you got there, though. All right, next up, we're going to talk about rational exponents. Rational, fractional, which just means exponents that are fractions. So first we'll focus on just 1/2. So if you have a, let's say, to the 1/2 power, that's the same thing as taking the square root of a, which you may have seen before. One thing you want to start thinking about is what this tells us is that the numerator tells us what power to raise it to, and the denominator tells us what root to take. So power over root, power over root. And we're taking the second root, which is just the square root. So let's try 8 to the 1/2 power. What does that mean? Well, 8 to the 1/2 power means we're taking the square root of 8. So in simplest radical form, we would take out the largest perfect square, which is 4, and the square root of 4 is 2. So we would get 2 rad 2. Let's do 1/81 raised to the 1/2 power. And with these, as we're doing these and as you do your practice on your homework, it's really, really important that you make sure you show the work that I'm showing here on the notes, because I don't want you guys just typing them in your calculator. I would love it if you type it in your calculator to check, but not to just do the problem. So here we're taking 1/2 power, so that's the square root of 1/81, which we can separate that into the square root of 1 over the square root of 81, and that gives me 1/9. Now let's do it with variables. So x to the 5th, y to the 6th, raised to the 1/2 power. Okay, so since we have a 5 in here, if I just power apply these, 5 isn't going to divide by 2 evenly. 5 times a half doesn't give me a nice integer. So I'm going to rewrite this as x to the 5th, y to the 6th underneath the radical. And now I'm going to put it into simplest radical form, which we've done before. So I'm going to separate it into 2 radicals. My first radical is going to be my perfect squares. The second is my non-perfect squares. So first I look at x to the 5th. I take the largest perfect square, so the largest even number before 5, which is 4. And then in here goes my x to the 1st. So x to the 4th times x to the 1st would give me x to the 5th. Y to the 6th is an even number. And remember, even numbers are perfect squares when they are in the exponent. So that's going to go in my first radical. And now I can take the square root of this first radical to get x to the 2nd, y to the 3rd. I'm just dividing them by 2 when I take the square root if they're exponents. And that would be my final answer. And one more, let's do x to the 6th, one more of these 1/2 powers, that is. So now we have this to the 1/2 power. Now this one, since they're both even, you can rewrite it like we did up here, or you could power apply it too and just say 6 times a half would give me 3, and 8 times a half would give me 4. So you can power apply that. Or if you wanted to, if it's easier for you to see it like this, rewrite it as a square root and then get the answer that way. Either way is fine. So now let's take it a step further. If we take it and we have just a to the 1 over r. So that means, again, like I said before, it's power over root. So we're raising it to the first power and the rth root. So that would be like taking the rth root of a. So the second root would be square root. The third root, or the cube root, would be if r was a 3. So here, I want to move my 15 down a little bit. So I have 27x to the 9th raised to the 1/3 power. So that means the 1/2 power is the square root. The 1/3 power is the cube root. So I'm taking the cube root of 27x to the 9th. So you can find the cube root of 27 in your calculator. If you don't know it off the top of your head, you can type in 27 to the 1/3 power, or you can go to your math menu and then use the cube root from there in your calculator. And then here you could also power apply that, like you power applied this. 9 times 1/3 is like 9 divided by 3. So that would be x to the 3rd. Either way you do it, you need to find the cube root of 27, which is 3. 3 times 3 is 9. 9 times 3 is 27. And then take the cube root of x to the 9th, which is x to the 3rd. So either way makes more sense. A lot of students actually like doing it this way, where you're power applying. It makes it easier for the second one. And 27 to the 1/3, you can just type right into your calculator. Let's do 32x to the 10th raised to the 1/3. So here, or sorry, let's not the 1/3, 1/5. So now we're doing the 5th power. And when you write that, make sure it's inside the hook so it doesn't look like you're doing 5 times the square root. Like that, or you could do 32 has an exponent of 1, so power to a power, we power apply. 32 to the 1/5, and x 10 times 1/5 is like 10 divided by 5, which is 2. And then that's a 2 there. And then you can type 32 to the 1/5 power in your calculator, or again, go to your math menu in your calculator and choose it there, and that should give you 2. And then keep your x to the 2nd. And 16a raised to the 1/4 power. So add in the variable again. So here we're raising 16 to the 1/4 power and a to the 1/4 power. So again, type in your calculator 16 caret 1/4, or you can use your math menu in your calculator to find the 4th root of 16. Either way is fine in your calculator, and that should give you a 2. And then we don't want to leave any rational exponents ever in our answer, so we're going to rewrite this as the 4th root of a, because we can't simplify that any further. All right, now let's talk about if we have the a raised to not a 1 on the top, but it could be any number. So we say that's a raised to the power over root. Power over root, power over root. So this would be the rth root of a, and then raised to whatever number's on the top. So before it was just a 1, so it's being raised to the 1st power. So for example here, change colors so that stands out a little bit. And I'm on to my next page. We would do, what number are we on? Sorry, 18. So if I had 25 to the 3/2 power, the 3 is my power, the 2 is the denominator, that's my root. Power over root, power over root. So this would be the square root, the 2nd root of 25, raised to the 3rd power. And it actually is the same as if you had done 25 to the 3rd power and then take the square root. That'll give you the same answer. But that's just harder for us to do in our heads. So I'm going to take the square root of 25 as 5 and cube it, and that would give me 125. Okay, so now try this one, 64 to the 2/3 power. Pause the video and try that on your own. Okay, so you should have had the cube root of 64 and then raise that to the 2nd power. So again, you could do 64 raised to the 1/3 power to get that, or you can go to the math menu on your calculator and do the cube root of 64, which should give you 4 squared. I don't know why it's giving me all these extra stuff now. 16. And if you typed in 64 raised to the 2/3, it would give you 16. So it's a good thing to use your calculator to check. But again, I want to see the work so I know you know how to set these up as well. Okay, let's try -4 raised to the 3/2 power. Pause the video and see if you can set that one up. All right, so 2, it's power over root. So the root is the 2nd power, which means it's the square root of -4. And we're raising that to the 3rd power. Okay, so what's the square root of -4? Oh, it's a negative under the radical. Pull it out. It becomes 2i raised to the 3rd power. Then 2 to the 3rd. Don't forget to raise that to the 3rd as well. It's going to be 8 and I to the 3rd. Oh no, I can't leave an I with a power other than 1. So you can use your I circle here. You can type in I to the 3rd into your calculator to figure that out. If you're using your circle, you have -I and I, 1 and 1. So, actually, let's flip that. So we can start at the top. So we'll do I and negative I, -1 and 1. So then I to the first is I to the second is -1, I to the third is negative I. So I replace I to the third with negative I, so I get -8 I for my answer. Okay, let's try another one. Let's do 12 raised to the 3/2 power. Pause the video, see if you can at least rewrite it, and then we can go over the rest together. All right, so hopefully you did the square root of 12 raised to the 3rd power. So from here, we want to try and simplify this. So it's not an even exponent. So really this is like saying rad 12 times rad 12 times rad 12. Well, I know that rad 12 times rad 12 gives me 12. But now this is not in simplest radical form. So I'm going to break up rad 12 into the square root of 4 and the square root of 3. And I'll bring this down. So now the square root of 4 is 2. So I have 12 times 2 times rad 3, which will give us 24 radical 3. Okay, I think that was 21. Next, x to the 6th raised to the 2/3. So here, instead of actually rewriting it using the power over root, I would say first power-ply them to simplify it. So 6 over 1 times 2 over 3. And you can use your calculator. 3 goes into 6 twice. So that gives me 4. So I'm just left with x over 4. So on that one, we just power-ply. And we don't need to simplify that any further because it's an integer. All right, try 1 over 64 raised to the 2/3 power. Pause the video and try that one on your own. All right, so power over root, power over root, power over root. So the root is the 3rd root, so we're taking the cube root of 1 over 64. So I'm going to go straight to separating that into my numerator and denominator, and then I'm raising that whole thing to the what power? 2nd. All right, so now the cube root of 1 is 1. 1 times 1 times 1 is 1. And the cube root of 64 is 4. Again, you can use that in your calculator. You can use the math menu for the cube root key, or you can also type in 64 raised to the 1/3 power. And then we're squaring it. 1 squared is 1. 4 squared is 16. And try this one, pause the video, and do this one on your own. Again, this is another one where you want to power apply. So 3 times 1/3 gives you 1. So your answer is just x. All right, and the last thing we're going to talk about are negative rational exponents. Negative rational exponents. So when we talked about negative exponents, we said we need to take the reciprocal when we do negative rational exponents. So negative exponents at all. So you should be thinking reciprocal when you see negative exponents. So for example, if you have a to the negative p over r, that would become, you'd flip it, so it'd become 1 over a to the positive p over r. So you flip it, and then you have your power over root. So let's look at an example here. If I did 25 raised to the negative 3/2 power. So the first thing I would do is I'd get rid of my negative exponents. I like to usually start out by doing that. So that'd be 1 over 25 raised to the positive 3 halves, because right now it's in the numerator. So it would go to the denominator, become positive, but you're not flipping the exponent. You're just putting the whole thing, the base with the exponent, to the denominator. Now I have power over root. So I'm taking the square root, the second root of 25, raising that to the third power. So that would be 1 over 5 to the third, and then 5 to the third is just 125. Okay, try another one. Do negative 64 raised to the negative 1/2 power. Pause the video, see if you can do that one on your own. Okay, so negative exponent, so I say stay or go. It's going to go. Right now it's over 1, so negative 64 to the 1/2 power. Now that becomes positive 1/2 on the outside. 1/2 power is the same as power over root, so that is our square root, the second root. So I'm going to take the square root of 1 and the square root of negative 64. Well, the square root of 1 is just 1, and the square root of negative 64, well, I know the square root of 64 is 8. And since there's a negative, I want to pull that out and make it into an I. Oh no, but there's an I in the denominator. We're not allowed to have an I in the denominator, so what do I do to get rid of it? Well, hopefully you remember you need to multiply it by itself. So we're going to multiply both the top and the bottom by I. And the reason we do that is because, so 1 times I is I. Now I have 8I squared. And 8I squared, think back to your I circle or in your calculator. I squared is negative 1. So it gets rid of an I if you have it to the second power. So then this would be I over 8 times negative 1. So that would be I over negative 8. Or we usually write the negative on the top. Oops. It's be negative I over 8. All right, and let's try 25 to the negative 1/2 power. Pause the video and give that a try. All right, so again, that's negative 1/2 power. So first thing I'm going to do is flip it. So this is over 1. So now it's 1 over 25 raised to the positive 1/2 power. And the 1/2 power is power over root. So that's the second root, which is the same as my square root. So I'd end up with 1 over 5. And let's do one more. And that's going to be, I want you to try this one on your own. It's here. So I think this was 28. Be 9 raised to the negative 3/2 power. Pause the video and try that one on your own. All right, so we flip it, so it becomes 1 over 9. And that's raised to the positive 3/2 now. And power over root. So that would be the square root of 9 raised to the third power. The square root of 9 is 3. And 3 to the third would be 27. So 1 over 27. Again, that can be checked in your calculator if you just type in 9 raised to the negative 3/2 power. But I'm expecting on your homework to see all the steps written out like I did as well. All right, that's it. And if you have any questions at all, of course, come and see me. And I hope to see you all soon. Bye out.